Hello, in this video we're going to talk about the trigonometric identity, which is the Pythagorean identities, or the very famous trigonometric identity. So as you know that you have learned three types of identity. As you know, there's sine square theta plus with cos square theta equals 1. Alright, the first identity for trigonometric. So, and the other one will be tangent square theta plus with 1 equals to secant square theta, right? This is the second identity, and the next one will be the 1 plus cotangent square theta equals to cosecant square theta, right? This is the three identity that always when you study when you study trigonometric, this is the three identity that always appear, right? So now in this case here, how to prove that, you have to have some knowledge of proving this Pythagorean identity. So it's always start from a triangle, a right angle triangle. So trigonometric is very related to right angle triangle, right? Usually we will use right angle triangle to prove something. So for example, you have A, you have B, you have C, right? So as this is your angle, right? It's acute angle. So if you look at this, this is a right angle triangle, right? Right angle triangle, which the hypotenuse and the side that opposite to theta, this angle here is the opposite side, right? So this will be adjacent for this angle, the side for this angle, and this is the side that opposite to this right angle is the longest side, which is hypotenuse, right? So as you from here, you know that the definition here, sine theta, right? For sine theta, so the definition, the ratio will be the opposite side divided by the length of the opposite side divided by the hypotenuse, right? Hypotenuse. And cos theta is defined as the ratio of the adjacent, the length of the adjacent side divided by the length of hypotenuse. And tangent theta is defined as the opposite divided by the adjacent, right? So this is a very basic trigonometric ratio, right, that you learn during your secondary school. So now, if you look at this, this is very related, because why we name it as Pythagorean identity. Pythagoras relate to Pythagoras. Pythagoras said that a power of 2, the square of the side of a square and b square, a square plus b square will be the same as the hypotenuse square, right? This will be the Pythagoras theorem, right? Your Pythagoras theorem here. So then trigonometric is slightly improved the Pythagoras theorem into relate the side with the angle, right? Relate the side with the angle. So now, okay, I can take this equation. This is an equation. So the Pythagoras theorem, Pythagoras theorem. So I can divide everything by c square. I can divide this whole thing by c square. All right, I divide by c square. So I divide it by c square, right? So the purpose here is to get a 1 here, right? C square, I get 1 here. So as I factor out the power, is a over c power of 2 plus with b over c to the power of 2, right? Based on index law, right? So if you see that a over c will be sine theta, right? It will be sine theta. So sine theta power of 2 plus with b over c cos theta power of 2, which is equals to 1, right? So if you see that, this will be sine square theta plus cos square theta equals to 1. So this will be your Pythagorean identity, the first identity here, because why? It's generated from a Pythagoras theorem, all right? And this is the very close relationship between this and Pythagoras. So sine square plus cos square will be always equals to 1, right? If here is 30, sine square 30 plus cos square 30, it will be also equals to 1. As long as the angle are identical, then this product, the value will be 1, right? So then how to get the other two identity, right? From this, you get from the Pythagoras identity. So now, I can using this identity to improve to getting the other two identities. So, okay, let's see. Sine square theta plus with cos square theta equals to 1, right? So I can divide everything by sine square, right? I can divide everything by sine square, all right? Divide 1 by sine square theta, right? So I just divide by sine square theta. Sorry. Okay, I divide by cos square theta first, right? I follow the order. But cos square theta, so sine square theta over with cos square theta plus with cos square theta divided by cos square theta will be equals to 1, right? As you know that tangent theta is also the ratio of sine theta to cos theta, right? Sine theta to cos theta. So as you know that here, you see that sine over cos, sine square over cos square. So it will become tangent square theta, right? And cos square, sorry, this one you also need to divide by cos square theta, right? Everything need to divide by cos square over cos square. Cos square over cos square, you are getting 1. And 1 over cos, also back to the same thing, you need to understand the reciprocal. If you have secant theta is 1 over cos theta, right? And cosecant theta is defined as 1 over sine theta. Alright? So, if you look at this, 1 over cos, 1 over cos theta, 1 over cos theta square, right? So, 1 over cos theta is defined as secant theta, right? It's defined as secant theta. So, secant theta square, which will give you secant square theta. There's come a second identity. Alright, the second identity. So, okay, I'm going to generate the third identity, the third one. So how? By using the same, this one, sine square plus cos square equals to 1. By divide the 1 with sine square theta, right? Just now divide cos square, now you divide sine square. So divide by sine square, so you have sine square theta over with sine square theta plus with cos square theta over with sine square theta equals to 1, right? 1 divided by sine square theta. So sine square over sine square definitely get 1. So I can write for you here is cos theta over sine theta square. This one will be 1 over sine theta square, right? So 1 plus cos over sine is also defined as cotangent theta, right? Then the square here you have 1 plus cotangent square. So 1 over sine is cosecant, right? Cosecant theta square. So will be cosecant square theta, right? So there's come the third one. Alright, so this is the three formula, Pythagorean identities. The three Pythagoreans. This is the Pythagorean identities. So I hope you understand. And in the next video, I'm going to show you how to prove identities, or how to using this Pythagorean identity by proving another identities. Alright, another identities.